All right, let's look at question 12. So question 12, there's a Lewis structure of this nitrous acid. Just to take note now, they do not call it Lewis structure, they will call it Lewis formula, okay, which is the same thing. So they are asking you to identify which bond and between N and O is shorter. So what we are seeing is that we are seeing an N and O single bond, and we are seeing an N and O double bond. So the concept that we are covering here is that double bond is actually stronger than a single bond. And as a result of a stronger bond, so a double bond, the NO double bond is going to be shorter. Okay, question 12b. Deduce the value of the H oxygen-nitrogen bond angle in this acid. So let's look at the drawing. H bonded to O to N. So we are asking about this particular bond angle, and on top of that, there's two lone pairs. So what we are seeing is that we are seeing a 4-electron domain. 4 electron domains. Out of the 4 electron domains, we are seeing 2 bond pairs and 2 lone pairs, which is very similar to the water H2O structure. So 4 electron domains will put itself under the electron geometry of a tetrahedra, which has a bond angle of 109.5. So with every lone pair, it causes a compression of the bond angle, because lone pair repulsion is much stronger than a lone pair bond pair repulsion, and which is much stronger than bond pair repulsion. So therefore, there will be a compression of the bond bond angle because of the two lone pairs over here pushing each other away. So we expect an approximate 2.5 degrees of compression per lone pair. So if I make that estimation, it will be minus 5 degrees, so about 104 for the bond angle. So I will put down the angle as 104, and my explanation will be just there are 4 electron domains, and out of the 4 electron domains, there are 2 bond pairs, 2 lone pairs, and that's part of the explanation. Another part is that the lone pair repulsion is much stronger than the lone pair bond pair repulsion, and is much stronger than the bond pair repulsion. So that leads to a compression of the bond pair bond angle. Okay, that's for question 12b. Next, we are going to question 12c. So ammonia is a weak base. Deduce the Lewis formula of ammonia and state the name of the molecule and explain why it's polar. So let's draw out ammonia. Ammonia consists of nitrogen, which is group 5, hydrogen, 3 of them. So we are expecting to draw 8 electrons. So with N, H, minimum 1 bond each, I've used up 6 electrons. So left 2, I will give to nitrogen. So that's the Lewis formula of the ammonia, Lewis formula. So the name of this molecule is a trigonal pyramidal because it looks like a triangle pyramid. And we can see that NH bonds are polar. Right? So as a result of this NH bonds being polar, we are seeing a dipole moment being generated. And as a result, because the shape is not symmetrical, so the dipoles do not cancel out. And as a result, because the dipole moments do not cancel out, there is a net dipole. And hence, NH3 is polar. That would be the answer for question 12.